We're going to explore in this video a little bit about position graphs and velocity graphs and going between them. Alright, so we'll start with this position graph right here. We have some object that starts at this position of -10. It moves, goes all the way to 2, or at 2 seconds it stops at 40 meters, stays there, turns around, stops, and then goes back. Okay, and it looks like this point is a little bit redundant. So our goal here, though, is to make a velocity graph. We're going to basically break this graph up by the segments you see here. So from 0 to 2 seconds, we've got something going on. Then from 2 to 3 seconds, there's something going on. Then from 3 to 5. From 5 to 7. And then from really 7 to 10. Alright, so we have all these segments. We're going to graph this out. We want to graph this one that will be velocity versus time. For this first segment, how do we find velocity from this graph? How do we find the velocity of this segment? Well, what we're going to do, find the slope. So the rise over the run. So it goes up 1, 2, 3, 4, 5. That looks like 50 meters. And it takes it 2 seconds. So something traveled 50 meters in 2 seconds, giving a velocity of 25 meters per second. So that means that up here we've got something starting at 25 meters per second for 2 seconds. And then what would be the speed from 2 to 3 seconds? Looks like it stopped. It's not moving. It stays at the same position during that time. So that would be 0. Okay. Then from here, from 3 to 5, we're going to go, looks like about 60 meters in about 2 seconds. Notice though it's going in this negative direction, so this is going to be a -60 in 2 seconds, or -30 meters per second. Alright, go ahead and find the velocities for the last 2 segments and enter them in the box on the side. For this segment you should have got 0 meters per second, and for this one going from -20 to 10 in 3 seconds should be about 10 meters per second. So we graph those, we go here, and we go about here. Okay? So this is a velocity graph that we have now created using our position graph here to the left. It's very disjoint. In reality, it wouldn't make sense to instantly go from 25 meters per second to 0. It would probably be a little bit curved, and we'd probably see a little bit of a jump right here, or a little bit of a line connecting them instead of the jump that we see as it is. So now we're going to look at a velocity graph. So on the vertical axis here we have velocity in measured in meters per second, and our horizontal axis is seconds. Before we dig too deep into this graph though, I just want to ask you a quick question. So during these first 3 seconds we see that the velocity was 15 meters per second. So the question I have for you is, how fast is this object traveling, or not how fast, but actually how far does the object travel in the first 3 seconds? Well, we know that to find velocity, we're going to multiply, or we use this equation, velocity is delta x over t, so displacement over time. We can calculate velocity, or the displacement, by multiplying velocity times time. If the velocity is 15 and time is 3 seconds, that'd give us a displacement of 45 meters. And we're actually going to keep track of this right now. So we're going to say that at 3 seconds we've traveled a total of 45 meters. Okay. Now I want to show you something. If I were to draw a rectangle here and shade it in and find the area of this rectangle, what would be the area of that rectangle? Now before you figure it out, I want you to think about one thing. These numbers here have units. These numbers here have units too. So when you do an operation here, units are part of it. So go ahead and do that calculation, and when you give me your result, give me the units of it as well. So hopefully what you see is that you get the same thing by finding the area of this box. So if you multiply the 3 seconds, the width of 3 seconds times the height of 15 meters per second, then we get 45 meters, okay, which is the displacement for those first 3 seconds. When we're looking at graphs, we've already spent some time talking about slope. That's one way we can analyze graphs. What I want you to see here is that we have now a second way. We can use area to analyze graphs too. Sometimes the slope of a graph is meaningful. Other times the area beneath the graph is meaningful. Now when I say area beneath the graph, I don't mean all of this area right here. I mean the area between the graph and the axis. Okay, so if we want to find the total distance traveled or the total displacement of this whole trip, we're going to continue in this process. So we would want to go ahead and find the area of this shape. Now this is a kind of a tricky shape. I'm going to recommend breaking it up actually into 2 shapes. So I'm going to break it into right here a trapezoid and a triangle. When I find the area of this trapezoid, I'm going to say use this and this as 2 of the bases. That would be 15 plus 20. Okay, we're going to divide it by 2 to get their average. That's the formula of a trapezoid. And we'll multiply this by the height of 2. So the 2's will cancel out. And we're going to get, these by the way are meters per second. When we multiply that by the 2 seconds, we're going to get a displacement of 35 meters. Which means we've traveled by 5 seconds an additional 35. Okay, which would place us at a total displacement of 80 meters. Alright? And now we would need to find the area of this little triangle here. So that would be 1 second. We have a height of 20 meters per second. Remember, the area of a triangle is the base times the height divided by 2, or times 1/2. And so that's going to give us another 10 meters. So at 6 seconds we've got another 10 meters. Go ahead now and find the area of this next piece from 6 seconds all the way to 9 seconds. You can do it as one shape. This is one triangle with a base and a height. We're going to say that this point right here is -20 in case you're having trouble telling. So when you do this, this has a negative height, -20 meters per second, times our width of 1, 2, 3 seconds, divided by 2. So -20 times 3 over 2, going to give us 30 meters, -30 meters. Which means that from 6 seconds to 9 seconds, I made a mistake here. So this was an additional 10. That put us at 90. And then from 6 seconds to 9 seconds, it turns out that we actually went backwards 30 meters. Okay, so at this point right here, at 6 seconds, the object turns around and goes the other direction. Okay, it goes in the negative direction. Okay, at this point right here, it begins to slow down until it comes to a stop. So during this entire time, you have an object that's traveling in some negative direction. Okay, and so 90 minus 30 is 60 meters. Okay, so we can go ahead and we're going to sketch this into a graph. Before we do, I want to look a little bit more at this graph. So what can you tell me about the velocity from 3 to 5 seconds? If you look carefully, it says the velocity is increasing. It started at 15 and then it ended up at 20. That would be an increase in velocity. What's happening at 5 seconds? At 5 seconds, the velocity starts to change. it was speeding up before, and now it's starting to slow down. What's not happening is it turning around. It's not turning around here. Okay? Then, at this point, you're going to see the velocities decreasing, going from 20 to 15 to 10 to 5 to 0. It stopped right here. Then it's going to turn around and go the other way. Okay, speeding up in the opposite direction, then slowing to a stop. So we're going to go ahead and sketch a graph to go with this, and it's not going to be exact, just going to be a sketch. I'm going to kind of mark out the key points here. Okay, so the first part, we have some positive constant velocity. We started at 0, and at 3 seconds we'd gone 45 meters. So it's going to look like this. Okay, and then what you're going to notice from there, the speed increases to 20, and we go at 35 meters in those 2 seconds. Okay, so additional 35 meters. And so what happens is this line actually going to curve. Why is this line curving? Why is it getting steeper? It's getting steeper because the velocity is increasing, so it's going faster. But at this point, it turns around. Or doesn't turn around, it starts to slow down. So now the curve is going to change, because we still go additional 10 meters, but we're now rapidly slowing to a stop. So at 6 seconds where velocity is 0, our slope here is 0 and we're stopped. From there, we're going to go from 6 to 7. We'll actually break this into 2. This right here is probably about, this part right here is another 10 meters in the opposite direction. So we're going to kind of slow like this, start to speed up, and then right when it gets to this point, it starts to slow to a stop again. So that's going to look something like this. Okay, and then it's going to maintain that stop. It's going to stay there. Okay, so this is what our position graph would look like that corresponds with this. Notice I have these chunks of it where it's curved. Okay, these curves represent places where the speed is changing, and here at that last part you saw a point where it was slowing down. Okay,